In today's lecture, I am going to start with electric dipole. Uh, okay, so let's get started from electric dipole. Okay, let me start writing electric dipole. Okay, so what do we mean by electric dipole? Two equal and opposite point charges separated by a very small distance constitutes an electric dipole. So what does it mean? Two equal and opposite point charges separated by a very small distance constitute an electric dipole. Okay, like I have a charge at point A minus Q, and at a distance R I have point B, and at point B I have a charge plus Q. Okay, let's suppose forget about R. Suppose this is the middle point O, and from A its distance is A and small a, and from B its distance is small. Okay, so these two charges minus Q and plus Q constitutes an electric dipole. If I will have to give you some examples, then what will be the atoms or molecules of uh, NS3, HCl, H2O, etc. forms an electric dipole. Ammonia, hydrochloric acid, HCl, H2O, atoms and molecules of these for electric dipole. Okay, is it clear to you? So let's talk about our electric dipole moment. Okay, dipole moment. What do we mean by the word dipole moment? Dipole moment, we denote it as p vector. Okay, generally it is a measure of strength of electric dipole. It is a measure of strength of electric dipole. Okay, so how we define dipole moment? It is defined as the product of magnitude of either charge with separation between the charges. Okay, mathematically we can denote it as q, the magnitude of either charge, q into the distance between them is 2a vector, or we can say its magnitude is q into 2a. Okay, okay, so some few points about dipole moment. It is a vector quantity. Remember one important thing here, that its direction is always from negative to positive charge. Negative to positive charge. Okay. And its unit, what dipole moment has unit. Dipole moment has unit q into 2a, means coulomb into your meter. Coulomb into meter. Okay. In CGS you can write it as start coulomb into centimeter or half coulomb into centimeter. Okay. So let's talk about ideal. Let me change the color of the pen. Yes. Ideal electric dipole. Ideal electric dipole. What do you mean by this? An ideal electric dipole is that whose separation between the charges goes on decreasing and magnitude of the charges goes on increasing. Means separation between the charges goes on decreasing and magnitude of the charges goes on increasing. Okay. Then we named it as ideal electric dipole. I can denote it in short as Q tends to infinity and R tends to 0 or A tends to 0. Okay. Increasing such that, remember one thing, such that dipole moment remains constant. Remains constant. Okay. Okay, fine. Some important points about the dipole moment position or dipole positions, like let me choose that for you. Okay. Okay, we are good to go. Yes. I have dipole consists of charges minus q and plus q, and on the axial line, this is the axial line, remember this is the axial line, and if I draw the equatorial line, that is a line perpendicular to the dipole like this is my equatorial line, because in later we will have to find the electric field intensity due to dipole on axial line and due to equatorial line. Okay, you should remember that what do you mean by equatorial line or what do you mean by axial line. Equatorial line, and this is my axial line. Okay, we also call the equatorial line as Gordon line. Okay, just to remember these things. Okay, let's move forward. Okay, fine. Okay, so some if very important long question here comes: electric field intensity at any point on the axial line of an electric dipole. Let's derive this. Electric field intensity at any point any point on the axial line of an electric sorry of an electric dipole. I would recommend you to watch the video in 1.5x speed. That will be easy for you, okay, because I am teaching it at a slow rate. Okay, so let's start. uh, it's up to you how you watch this. Okay, you can watch it on 1x speed also, according to your convenient. Okay, I don't have any issue with it. Let's take the dipole as this one is A point and this one is B point, and we will draw the axial line like this. Okay, and this is the center and this is A and this is A distance. Here is my minus Q charge and here is my plus Q charge. I will take a point at a distance P at a distance R from the origin, from the center of the dipole. This one at a distance R. Okay. Okay, fine. And this one, let's take it as x-axis. Okay. Let us consider an electric dipole AB formed by two charges minus q and plus q having dipole length 2a. You will have to write it like this, so that you can get full marks in writing a long question. Okay. Let u1 vector is equal to electric field intensity at the point P due to charge plus q at the point B E1. So E1, if I will write the expression 1 by 4 pi epsilon naught q divided by the length is BP, becomes, okay, we are good to go, BP square along px, isn't it? So I can write it like this, q divided by r minus a square along px, isn't it? You see from here. Okay, let me zoom it a little. Okay, let's give it equation number 1. If I will write its magnitude, then I will write it like this, u1 mod is equal to 1 by 4 pi epsilon naught q upon r minus a square. Give it a equation number 2. Similarly, E2, let E2 electric field intensity at point P due to charge minus q situated at the point minus q is at which point? A, isn't it? So if I will write the expression for E2, what I will write? E2 is equal to 1 by 4 pi epsilon naught minus q. As we are taking the magnitude only, so I will write like plus q a p square along, the direction is along py, If this one is along px, then the E2 is along py. Okay, py, this will become 1 by 4 pi epsilon naught q divided by r plus a square along py. Give it a equation number 3. E2 magnitude will be equal to 1 by 4 pi epsilon naught sorry 1 by 4 pi epsilon naught q divided by r plus a square, isn't it? Give it a equation 4. Okay, so now compare equations 2 and equation 4. You can see E1 magnitude is greater than magnitude of E2. Okay, as in E2 we have the denominator as r plus a whole square, and in E1 we have the denominator r minus a whole square. There is the difference. That's why magnitude of E1 is greater than magnitude of E2. Now the resultant electric field intensity will be that is E will be E1 magnitude minus E2 magnitude, and the direction will be along px, isn't it? Yes. So E1 is equal to 1 by 4 pi epsilon naught q divided by r minus a whole square minus 1 minus 4 pi epsilon naught q divided by r plus a whole square, and the direction will be along px vector, or I can take 1 by 4 pi. Sorry for the disturbance. Okay, we are good to start again. Okay, 1 by 4 pi epsilon naught taking outside of the bracket, and q is also common in both the terms, so q is taking outside, r plus a whole square minus r minus a whole square divided by r plus a, oh sorry, okay, r, what happened, something wrong with it, I guess. Okay, now it's good. Sorry for the disturbance. Okay, r plus a into r minus a whole square, I can write it like it, isn't it, along the direction px. Yes. So what next? It will become, we have the formula a plus b whole square minus a minus b whole square. It will become 4ab, so it will become 4ra divided by r square minus a square whole square along px. Okay, so next q, if I will take q inside the bracket, then what it will give us? 1 by 4 pi epsilon naught q into 2a, give it a bracket, and into 2r divided by r square minus a square whole square along your px direction, and 1 by 4 pi epsilon naught, we know q into 2a is what? P, that is your dipole moment, into 2r divided by r square minus a square whole square along px. So finally what we get, 1 by 4 pi epsilon naught 2pr 2pr divided by r square minus a square whole square along px. This is our final expression for electric field intensity due to an electric dipole at axial line. Okay. Sorry. Okay. Give it a bracket. Okay. If I will write the magnitude part only, then what I will write? I can write it like this: 1 by 4 pi epsilon naught 2pr. What is happening with it? R square minus a square whole square. This is the magnitude. Give it a equation number 5. Okay. Let's see a special case here. Special case. Oh, what is happening? It's not working. Sorry. Yes. Let's see the special case, and this is the last one of this lecture, probably. Special case. For the special case, if we consider if the dipole is very short, is very short, that is ideal electric dipole, ideal electric dipole, then A is very less than R. So E vector becomes what? 1 by 4 pi epsilon naught 2p. We have here what? 2pr as 2pr divided by r square minus a square whole square. As A is very less than R, then we can neglect A, so we can write it as R4. So it will become what? 1 by 4 pi epsilon naught 2p upon R cube. This is the final expression for special case, that is for ideal electric dipole. So for today I will end this lecture, and in the next lecture I will discuss about electric field intensity at any point on the equatorial line of the electric dipole. That is also a very important long question for your uh, annual examinations and for concept clarity also.